going to take the derivative of y equals ln of 2 over x squared plus 3. And we're going to do this one way, and then we're going to go look at it another way. So this is going to be a chain rule. ln's the outside, 2 over x squared is the inside. Natural log, you take 1 over whatever you're taking the natural log of, times the derivative of what you're taking the natural log of. Now, as a reminder, 2 over x squared, we would want to rewrite as 2x to the minus 2, so we could run our power rule. Bring the negative 2 down, that's a negative 4. X, decrease the power by 1, that's a minus 3. So that's the derivative of the first term. Derivative of the second term is just 0 because we're just taking the derivative of 3. This can be, you divide by a fraction, you flip it and multiply. So this becomes x squared over 2. This term, we're going to have a negative 4 in the numerator, but the x cubed is going to go in the denominator because of the negative exponent. So we see that we can cancel out 2 of the x's with 2 of those. The 4 is going to reduce with the 2. And when all's said and done, we end up with 2 over x. Oops, don't lose that negative 2 over x. All right, I want to look at an alternative way of approaching this one. And that is to rewrite this at the beginning with a property of logs. ln of 2 over x squared could be rewritten as ln of 2 minus ln of x squared plus 3. And we have another property of logs that allows us to pull the exponent out front. So this would be ln of 2 minus 2 ln of x plus 3. So now when we go to find our y prime, well, ln of 2 is a constant, so it's 0. The derivative of minus 2 times ln of x, well, that's minus 2 times the derivative of ln of x, which is 1 over x. And the derivative of 3 by itself is a constant, or 3 is a constant, so its derivative is also 0. So minus 2 over x. So we get the same thing both ways. I just wanted to show you that option. Sometimes when we have logs in the original function, we can do some simplifying to make our derivative a little bit easier.